True, there are 180 degrees in every triangle, and I'm going to put a fancy theorem to it. It's called the triangle angle sum theorem, which said the following. All interior angles of a triangle add to 180. All right, we all know that. I just want to put a little name to it now called the triangle angle sum theorem. All right, all interior angles add up to 180. All right, let's put it to use. Problem number one, we got one triangle, so you might want to, if you want to, it's up to you, draw yourself a diagram. One angle I have as 2x in example 1. The second angle is x plus 10, and the third angle is 3x minus 10 in this triangle. First one, part A, find x. So I need somebody, can you set up an equation to find x for me right now that you know all three angles in the triangle? Let's come up with an equation to find x. Let's roll. Hayden, here we go. Give me an equation to find x.
2x plus x plus 10 plus 3x minus 10 equals 180.
Okay, pretty straightforward, everyone. 180 degrees in a triangle. Boom, here I go. I'll give you guys a second. Go ahead, solve for x. When you get there, let me know. Even if you're not finished, that's fine. I just want to let somebody know they're going to give me the answer here. Value of x whenever it's ready. Here you go. Ellie, whenever it's ready. Value of x.
30.
30, good job. X is equal to 30. Part B, okay, now find each degree measure. So everyone take your 30 degrees we just found and plug it back in for x for each of the three angles. And somebody will tell me here in a second what are the three angles. So go ahead, plug it back in. Okay, when you're ready, what are my three angles? Here we go. Ryan, what are my three angles?
40, 60, and 80.
40, 60, 80. Good job. All right, plugging them in. All right, now, maybe a little bit tricky for some of you. Part C, what type of triangle is this? Based on its angles, not its sides, so I shouldn't have isosceles, scalene, or equilateral. Okay? All right, I should have, I'm not even going to say anything. So if you got to look back at day one notes, all the different types of angles for different types of triangles based on their angles, 40, 60, 80, I would put into what category for triangle? 17, Maeve, what type of triangle am I working with if I got degree measures 40, 60, and 80?
Acute.
Acute, good job. This is an acute triangle. I know it doesn't say to justify, but just so we're clear, acute triangle because all three angles are less than 90. All right. All good. Very basic right there. Very basic. Let's start upping the difficulty level. Maybe. Let's start upping it just a bit. All right, now I'm going to have a diagram here to see what this looks like. So triangle ABC. Real quickly, when you label a triangle, it doesn't matter what order or where the vertices go. All right. A, B, C. It doesn't, wherever you put them, you put them. It's not going to affect the problem ever. Angle A, I got 40 degrees. So let's pop 40 degrees in for angle A. Angle C, 30 degrees. Got it. Oh, and then I got a little something coming at you here. Segment CD is drawn. CD is going to bisect angle C here. And D is going to be somewhere on AB. So point D is somewhere on AB. And when I connect CD to make that segment, it bisects angle C. Here's the point of this, and I'll tell you what the point I want to get across by doing this problem is. Now I have three triangles in the diagram. Everyone agree I have three. I have the original ABC, I have DBC as a triangle, and I have ADC as a triangle. The point I'm trying to make here is no matter which triangle I look at, there's still 180 degrees in all three of them. Okay, a lot of people see a triangle within one and they think it's less than 180. No. Every triangle you see in that diagram has 180 degrees contained in it. Remember that as we go through the different parts. So if DC is bisecting angle C, anybody want to tell me the degree measures on each side here of 30 degrees now? What are each degree measure there that I just starred? 23. Here we go. Luke, what do you got?
15.
15 and 15. Bisect means cuts it in half, remember? So I got 15 degrees and 15 degrees. Perfect. All right, let's answer some of these questions. Part A, angle B. Okay, angle B. Remember our original triangle, ABC. Remember that original triangle, ABC? I had 40 and 30. How much is left over? Here we go. 15. What do we got? Will?
110 degrees.
110. If you're wondering, where did Will get 110? He did 180 in triangle ABC, 180 degrees, minus the 40 and the 30 that were given, and 110 degrees. Some of you may already do this, but anytime it's a multi-part question like this, A, B, C, D, etc., and you find one part, I would label your diagram with it because you never know. You may need it coming up. So I got 110. All right, let's keep trucking. Part B, ACD. We already found that, didn't we? ACD, 15 degrees. Done. All right. How about the measure of angle ADC now? ADC. Look at your diagram. ADC. Remember what I said at the beginning. Every triangle has 180 degrees, even if it's contained in another triangle. All triangles have 180 degrees. So what are we thinking here for ADC? Ooh, going deep. Hi, Emma. Good job, 125. If anybody's wondering, how did Emma get 125? She did 180 in triangle ADC, minus 40 that was given, minus 15 from the bisector. $125. Good job, Emma. 125. And then the final angle we need to find here, I'm running out of room, is the measure of angle BDC. And you could go about this a couple ways. You don't have to use triangle facts to find angle BDC. You can use something else from Unit 1. Oh, yeah, here you go. Emily, what's up?
55.
55. Couple ways Emily could have got 55. She could have seen that it was a linear pair with 125 and knew they were supplementary. Or she could have seen this triangle right here, BDC, and said there's 180 degrees in that triangle. A couple different ways to go about it. You kids all right? We good? All right. Let's keep trucking on to the honors level now. And you guys have 2 to 7 in your packet. All right, triangle ABC again. Very creative, ABC. Ooh, A and B are in a ratio of 2 to 7. Oh, okay. And the measure of angle C is 72. Whew. All right, let's talk about this 2 to 7 business, guys. Angle A, 2 to angle B, 7. Well, that doesn't make any sense, right? Angle A is 2 degrees, angle B is 7 degrees. That doesn't make any sense because it's got to add up to $1.80. All right, well, what if I just double them? Would 4 and 14 work? Nope. Let's stop playing this game of double, triple, quadruple. Anybody remember from our first unit, what do I need to do with the 2 and the 7 to figure out what I got to multiply by? You can, I won't ask. Go ahead. You can just tell me.
2x and 7x.
Put x's with them. Anytime you got those numbers in a ratio, put x's with them. That will tell me what I have to multiply by. All right, now that you have all 3 angles, can somebody come up with an equation so we can all solve it? Woo! Let's go, Anthony. Here we go.
2x plus 7x plus 72 equals 180.
Is this like the first time you've been called on all year, Anthony, by the generator?
pretty much.
Yeah, I was going to say, that's a new, it just didn't, that number there. See? Could be, what are we, 7 weeks into school? Could take you 7 weeks. Could be called on 3 times in a class. Who knows? All right, go ahead, guys. Solve it for x. When you're ready, let me know what you got for x. When you're ready. When you're ready. Maeve, what do you got? Speaking of a couple times in a class. 12? Yep, good. 12. Again, I've been preaching this to you guys all year, especially on your tests and quizzes. X doesn't mean you're done with the problem. Not in this case either. Find the measure of each angle. Each angle. So take 12, plug it back in, and let me know what angle A and angle B turns out to be. No pun intended. And if you're waiting for me to call on somebody, you can quickly check your work because all 3 angles should add up to $1.80. So when you get it, let me know what you have for angles A and B when you get there. Woo. Next, Owen, here we go. When you get there.
For angle A, I got 24, and angle B, I got 84.
There we go. 24 degrees, 84 degrees. Good job. All right, everybody all right with angles inside the triangle? All right, hopefully that was more of a review than anything, because now what we have to do is you can have an angle outside the triangle. An angle outside the triangle called an exterior angle. All right, that's our focus for the second half of today. Exterior angles. All right, this is where it gets fun now. All right, you love my, don't worry about the two, don't worry about these two here. All right, please don't copy those down. Don't worry about them. All right, I want to focus on the diagram I actually gave you, triangle ABC. You see 3 numbered exterior angles right there, hopefully. You see 3 numbered exterior angles. I just need somebody to start out with one of them. Give me 1 exterior angle in that diagram, please. Here you go. Sijin, give me 1 exterior angle in that diagram, please, so I can start filling out the chart.
Angle 1.
Okay, everybody, angle 1 is an exterior. Now, based off that, can somebody give me the adjacent interior angle to angle 1? Adjacent, hopefully you remember what that meant. If I'm at angle 1, what's the adjacent interior angle to it? And you can use the lowercase letters now. Woo! Luke, go ahead.
A.
Yep, lowercase a. New vocab time now. New vocab time. That's the adjacent angle to 1. The other 2 angles, the ones that are non-adjacent, we could refer to them as non-adjacent interior angles. Now, for me, that's a mouthful. So instead, I'm going to start referring to them as remote interior angles. The 2 angles that are not inside the triangle that are not next to the exterior one. So what would be those 2 angles in this case? If I'm talking about exterior angle 1. Here you go, 14. Here we go. Ellie, back to you. What 2 angles would be remote interior in this case?
Angle B and C.
You got it. Angle B and angle C. Those would be considered remote interior. The ones that are not adjacent to the exterior one. All right, 1 doesn't make us great. Give me another exterior angle. Oh, Ellie, up again. On fire today, 3 times. Poor Anthony gets 1 every 7 weeks.
Angle 2.
Good job. Angle 2. What would be the adjacent interior angle to that one? Boom. Oh, there he is again. Anthony, let's roll.
Angle B.
Angle B. See, it hurt us talking. The generator knows everything. It knows when you're not paying attention, when you haven't been called on. It knows everything. 7. Here we go. Back to Sinjin. What would be the remote interiors for angle 2, Sinjin?
Angle A and angle C.
Angle A and angle C. Yep. All right. Good, guys. I'm not going to even ask for the next one. We'll just fill it in here. It would be exterior angle 3. Angle C would be the one next to it. And the 2 remote interiors would be angle A and angle B. All right. All right, why are we going through all this? One, I need you to know that new vocabulary term, remote interior angles. But also, there is a relationship between all of these. There's a relationship. Let's find out the relationship, because I am not a big fan of giving honors kids just the theorem and that's it. I want you to try to find the theorem on your own. You don't need to copy these two diagrams down over to the right on the screen right now. Don't copy them down. All right, just focus in. So you guys see on my first diagram, I plugged in 30 and 70. 30 and 70 for my angle measurements. I need somebody to give me the missing angle inside the triangle and the exterior angle I just drew. So have your calc in front of you if you need it right now. What's the missing angle? And what's the exterior angle of that triangle? Whew. Sean, here we go. Going to you. What's the missing angle inside the triangle?
80.
80, good. And then how about my exterior angle?
150.
150, good. You guys probably don't see a pattern yet. Let me go to my next triangle now. Help me find the two interior angles that are missing of my triangle. 15, here we go. Will, what's the angle next to 120?
60 degrees.
60, good. So I have 60 and 50. What's the other missing interior angle?
70 degrees.
Good job. All right, now it's on you guys. I'm going to turn it over to you guys. Do you see any relationship between the exterior angle of each triangle and any of the angles inside? Okay, do you see any relation? And don't tell me linear pairs, supplementary. Okay, I get it. All right, we don't need triangles for that. Do you see any relationship between the exterior angles of both triangles and any of the interior angles? Dig deep. Come on, honors kids, dig deep. So what? Whoa. Let me teach here. All right, don't steal my fire. So you got 150 there. Any relationship between 150 and maybe some angles inside? I got 120 here. Got any relationship between the 120 and the angles inside? Go ahead now. You can show off.
The sum of the remote interior angles is the adjacent interior angle.
Maeve, that's pretty darn good. Good job, Maeve. Way to show off. Here's what Maeve just said, everyone. Look at my first diagram. I have an exterior angle of 150. Look at the two remote interiors, 80 and 70. They give me 150. Second diagram, 120. Look at the two remote interiors, 50 and 70. The exterior angle will always be equal to the sum of the two remote interiors. And that's the theorem. Here we go. An exterior angle of a triangle will always be equal to the sum of the remote interior angles. Look at that. Good job. I know more students had it too. All right, you guys all right there? Let's use it now. Let's use it. That's great. We talked about it. I want to use it now. Okay, here we go. I know you only have part A. I forgot to X out this one. You guys don't have that one in your packet anymore. All right, here you go. Find the number of degrees in X. Well, X, everyone, X is exterior. So it's got to be equal to the sum of its two remote interiors. So if I'm talking about exterior angle X, what are my two remote interior angles in that diagram? Hayden, back to you. What are my two remote interior angles for angle X?
40 and 90.
40 and 90. Got it? So that angle, exterior angle, is 130. Now I get it. Most of you guys could do this. Oh, well, Mr. Carlino, why do I need that? I could just do 40 plus 90 is 130. That's going to be 50, and these are supplementary. You could. No arguments for me there. You could. But there's going to be certain diagrams you can't do that. Take a look at the next one. Look at the next diagram. All right. Oh, this is my favorite one. Angle A, x squared minus 6x. Angle A. B, 2x minus 3. And ACD, that's the exterior angle here. 9x plus 27. What's the value of x? All right. Hey, this is an instance where you just can't say, oh, I'll subtract all the interior angles from 180 and say it's a linear pair. You can't do that here. Sorry, that's not happening. I have to know the theorem here. That's the only way I'm going to set up an equation to solve for x is if I know this theorem. So somebody help me set up the equation using the theorem. Who's with me here? Woo, Sabrina? Sabrina on here?
Yeah.
Oh, hi, Sabrina. Sorry. Ready? Okay, what's my exterior angle, Sabrina?
9x plus 27.
All right. The exterior is equal to, give me one remote interior, Sabrina, for 9x plus 27.
X squared minus 6x.
Yep. Plus, what's the other remote interior?
2x minus 3.
Are you another one that hasn't got called on recently, Sabrina?
I think so.
Okay. All right. He's generators just plucking kids out of the woodwork. All right, everybody good there? Where we got that from? Oh, you are not going to like this, and I love it that you're not going to like this. All right, let's clean up the right side a little bit. 9x plus 27 equals x squared. I can combine negative 6x and 2x minus 4x minus 3. Oh, this makes me so happy. Ooh, where do we go from here now? Got to solve for x. Where do we go from here, kids? Ooh. You got an x squared, don't you? You got an x squared. Oh, you know what time it is.
Do we have to factor?
Yeah, well, you're darn right we do. And I told you guys I'm not shying away from it this year. I know we're in geometry and it was an algebra topic. I'm not shying away from it. All right, so either we get more comfortable with it or we just ball up in the corner of your room and cry about it, I guess. Maybe some of your weekend plans right there. Okay? We got to figure it out. I cannot factor in this yet, though. I cannot factor unless one side is equal to 0. So I need to move some things over. So somebody help me move the 9x and the 27 over right now. All right, St. John, here we go. How do I move the 9x over first?
You subtract it.
Okay, and I know some of you guys could do the 9x and the 27 in the same step. I just want to show everyone that needs it where everything's coming from. So I'm going to do step by step. So I end up with 27 equals x squared minus 13x minus 3. Still not equal to 0 yet. How do I move the 27 over? Ooh. Oh, I told you! Anthony, let's go!
You subtract the 27 from both sides.
Darn right. So I get 0 equals x squared minus 13x minus 30, everybody. Minus 30. All right, yep, it's time now. All right, it's time now. And I'm not asking for a lot here. I'm not going to do all these different types of methods you had last year factoring. This is really the only one I'm going to expect out of you guys for now. And that's two numbers that multiply to this C value, negative 30, and add to your B value, which for us is negative 13. So that's what I'm asking you now. Crunch out some numbers for me that multiply to negative 30, but at the same time add to negative 13. That's all I'm asking. Not much, not much. Just find those two numbers for me. No, absolutely not. Somebody's giving me this, whether they want to or not. Two numbers multiplied with negative 30, but add to negative 13. Here we go. Whew. Sean, going to you. Got those numbers?
Negative 15 and 2.
Was it really that bad? Was it really that painful, guys? Negative 15 and 2. If some of you guys thought 10 and 3, I get it. They multiply to 30 and you could get a 13, but not with those signs. I can't do 10 and 3. All right, one last step, and that's to find the values of x. So 0 equals x minus 15. 0 equals x plus 2. So on this side, on the left side, it looks like x equals 15. And on the right side, it looks like x equals negative 2. Not bad, guys, not bad. I got an issue with that, though. I'm not comfortable. Not comfortable. And it's not because our algebra is wrong. I'm just, at this point right now, I am not comfortable leaving this problem. Not comfortable at all. Algebra looks awesome, but I'm not comfortable going to the next problem. Why? Anybody know why I'm not comfortable right now?
Because that wasn't the question.
The question was find x. I did. But I'm still not comfortable.
One of the x's isn't like the actual answer, it's like an extraneous answer, I think.
Whoa, easy with your big words there, Radhika.
Oh.
There's a problem. Yes, there is a problem with one of my answers, kids. We had a diagram at the beginning of this problem, correct? Everyone look at that diagram real quick for me. One of my answers was x equals negative 2. X equals negative 2. If you guys go up to angle B and plug in negative 2 for x, what's going to happen? I'm going to get what type of angle?
A -1?
Yeah, a -1. And until next year anyway, you can't have negative angles. All right, so negative 2 is not going to work for me. Negative 2 will not be a solution because when I plugged it in, it gave me a negative angle, which I cannot have. So what we need to do, go back down. So what do we need to do to negative 2? Fellas, probably the story of most of your lives, gets rejected. Okay? Gets rejected. Too harsh for some of you guys? Too harsh, even from home? Sorry, fellas. Truth hurts. So I cannot have negative 2 as an answer, so my only answer here is 15. Again, let me state this before we end the class today. I did not reject negative 2 because it was negative. I rejected it because when I plug it back into the problem, it gave me a negative angle, which is a no-go. All right, so don't just automatically reject negative answers. Plug it back in and see what happens. All right, you guys all right? I know we didn't get to the last two. That's not a big deal.
Yeah. It may sound stupid, but
nope.
Where is nowhere. Why can't you use -10 and -3?
Okay, -10 and -3.
Oh wait, because then that would be
that would multiply to positive 30, and I need negative 30. Okay.
Okay.
Yep. Good question. Anything else here, guys? All right, so the answers are up on Classroom like usual. Maybe be prepared to factor. Don't shy away from it. All right, you're fine. You'll be fine. Okay, get out in the corner of your room and start factoring. All right, good to see everybody. The test will be released later on tonight or this weekend if you want to see what you got right and wrong. All right, guys, have a nice weekend. Please be safe, be smart, mask up so we can get back together here soon. Have a good weekend, guys.
Are the packets outside in the main entrance like right now so we can go get them today?
They are right there, right now, waiting to be taken.
Great.
Okay? Have a good weekend, guys.